now going to look at an aspect of the course that's not really specific to any one particular chapter or section. In fact, it's covered throughout the course, and that's different strategies to solve puzzles or win games. And you'll notice in the textbook, if you have a copy of the textbook, that throughout the book there are little puzzlers that you can work on or look at, and there's also an example of a game at the end of every chapter that you can use to develop some different strategies for solving or winning games. So the outcomes we're going to cover are: we're going to determine, explain, and verify a strategy to solve a puzzle or to win a game. For example, we can use guess and check, looking for a pattern, make a systematic list, draw or model, eliminate possibilities, simplify the original problem, work backward, or develop alternative approaches. Identify and correct errors in a solution to a puzzle or in a strategy for winning a game. And create a variation on a puzzle or a game and describe a strategy for solving the puzzle or winning the game. Okay, so what I'm going to do is I'm going to go through a few examples here with you. By no means is this an extensive list of how you can solve different puzzles, but it's a few different strategies you can attempt, and hopefully you'll go and attempt some of these for your own and see if you can answer some of the games in the book. Okay, so the first question is a puzzler here. This is actually out of Chapter 1 in your textbook. A game show host asks you to choose among 3 doors, number 1, number 2, and number 3. Behind one of the doors, there is a new car. Behind the other 2 doors, there are rocks. The host knows which door hides the car. You choose a door. The host shows you a rock behind one of the 2 doors that you did not choose. He then gives you the opportunity to change your choice. Assume that the host always does this, no matter which door you guess. Should you change your choice? So again, you pick a door. The host will always show you a door of the 2 that you didn't pick where the car is not located. So the question is, when he gives you the option, would you like to change make a change to your choice? Should you change your choice? And the short answer is yes, believe it or not. It's actually a very simple answer. Yes, you should. And I could give you a long, drawn-out explanation, but I found a really good video that describes this exact scenario. This is actually right out of a game show from I believe from the 60s and 70s. Where people play this all the time. So the video can be followed by this link, and I'll post a link to the chat window. It's a YouTube video by a really good YouTube channel called Numberphile, and it describes, like I said, this exact situation. So I think it's worth your while to have a look at it, rather than having to listen to me all the time. You know, it's nice to hear a different perspective on some material that we've covered in this course. Okay, we're going to look at a specific type of puzzle. It's called the logic puzzle. Amanda, Kim, Alex, and Sarah each have different colored cars. One car is red, one is blue, one is white, and the other is black. Who owns which car? So we have 4 clues, and we can use it to determine who owns which car. So the clues are: Amanda's car is not red or white. Clue 2 is Kim's car is not blue or white. Clue 3 is Alex's car is not black or blue. And clue 4 is Sarah's car is red. So to solve something like this, we got to determine each different car color. It's often useful to use a graphic organizer. So we've got a table here. And what we're going to do is we're going to put X's for things that are not true, and we're going to put tick marks for things that are true. So in clue 1, it says Amanda's car is not red or white. So Amanda's car is not red. I can eliminate red. Get my pen working. I can eliminate red. And it's not white, so I can eliminate white. Kim's car is not blue or white. So Kim, I can eliminate the blue, and I can eliminate the white for Kim. And Alex's car is not black or blue. So I can eliminate blue for Alex, and I can eliminate black for Alex. And finally, Sarah's car is red. So we know Sarah's car is red. So we can say that Sarah's car is red. So that means we can do a lot here now. We can say that Kim's car cannot be red, and neither can Alex's. And we can also say that Sarah's car cannot be blue, white, or black. Now you may notice if you look at Kim's column, that leaves only one option for Kim's car. We know that Kim's car is not red because Sarah's is. We were told that it's not blue or white. So the only color that Kim's car can be is black. And Alex, in a similar fashion, we know Alex's car is not red because Sarah's has to be red. And we're also told that hers is in black or blue. So that leaves only one color for Alex, and that's white. And as a result, we can say that Amanda's car cannot be black. And we already know Amanda's car is not red or white, so there's only one color left for Amanda's car, and that's blue. So we could say Amanda has the blue car. Kim has the black car. Alex has the white car. And finally, Sarah has the red car. Now this was a fairly short logic puzzle with a very small logic organizer. You can get much bigger ones than this, of course, and there are different games like this in the textbook. Sometimes it's nice to give this kind of puzzle a try. It helps develop your logic, determining what is definitely true and what is definitely not true, and eliminating possibilities, and also determining true possibilities. Okay, the third type of game I'm going to look at in this video is a Sudoku puzzle. And I'm sure you're all familiar with Sudoku puzzles now. They seem to be everywhere. For a long time, they were just about everywhere you could see. There was books, they were in newspapers, they were on a lot of websites. Basically, the way a Sudoku puzzle works is that every row, so a row would be a cross, every row, every column, and every block of a 3x3 would all have the digits 1 through 9. So in order for that to be true, you can never have more the same digit in any row or any column or any block of 9 more than once, because it has to give you all the digits from 1 through 9. And it was a very interesting puzzle when it came out. You can get some fairly easy ones. You can also get some really difficult ones depending on the number of starting pieces you're given and also the location of those starting pieces. So I'm going to show you a few ways of deciding where to start with a problem such as this. Okay, so I'm going to clear the page off again. Here we go. So we're going to start with the fresh Sudoku puzzle. Now, some strategies you can use is, we know that every row and every column has only one of each type of number, one digit. What I would do to start with, I would look at the board here, and I can see that there are a lot of 8s on the board. There is one here, let's see, there's one here, there's one here, one here, one here, and one here. So we see a lot of 8s. Usually that's a good place to start. We already have a lot of the digits. Because there are 9 rows and 9 columns and 9 blocks of 9, that means that there is going to be 9 of each digit on the board. The fact that I already have 5 8s means that there aren't that many 8s left to be put on the board. And as a result, chances are I can find the placement of some 8s. So the first thing you will notice is that on the far left, we have an 8 in that column. So this whole column is eliminated for 8s. I can't have another 8 there because I already have an 8. Same with the third column from the left. This whole column, I have an 8. So I cannot put an 8 anywhere else. You'll also notice that the 8 on the far left is in the second block of 9 blocks. And the 8 in the right here is in the first block. So that means that my bottom block right here must contain an 8, but it's really, I've eliminated this column right here, and I've eliminated this column right here. So there's really only 2 spots for an 8 to be. Either we can have an 8, I usually put in a small number into the corner like this. I can either have an 8 here or an 8 here. That's really the only possibilities based on the columns. But now we're going to look at our rows. I can see an 8 right here, which eliminates this row. I cannot use this row because I already have an 8 in that row. Also, I do have an 8 right here, which means I can eliminate this row. So I've eliminated 2 columns, right here and here, and I've eliminated 2 rows from my possibilities. So there's only one place for this 8 to go now in this question. That is right here in the middle. It's the only place that I can place an 8 in this block of 9, the bottom block of 9, bottom left. Okay, so I'm just going to clear off the board. I'm going to place my 8 where I said it would go, which is right here. And I often will also set up a tally. There's all the digits from 1 through 9, so I'll have 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I've counted now 1, 2, 3, 4. I had 5 8s to start, and I added another one. So I have 6 8s used up now, and I only have 9 available to me. So that means there's only 3 more that I can put on the board. Well, I'm going to be able to find another 8. I'll do one or two more to get you going and let you work through the rest for yourself. I have this 8 right here again. I used that in the first placement, and I'm going to use it again. So this 8 is in the third row from the top. So that means this whole row can be eliminated. I cannot put another 8 in that row. Notice in the fourth column from the left, I also have an 8. So that's this column right here. Okay, I cannot put an 8 in that column right there. I also have an 8 down in the bottom, right in the bottom and in the middle of the board. So I can eliminate this column. So I cannot put an 8 in either this column right here, or this column right here, or in this row right here. So there's only one place that I can place the 8 in this block of 9 at the top middle, and that would be this position right here. So once again, I was able to put in another 8. So that gives me 7 total. Now that means that I only have 2 8s left to be able to place anywhere on the board. So I'll clear some of this off again. so we can simplify things. There we go. Okay. So I have only 2 8s to go on the board. So let's see if we can place those. If I look at, I'm going to look at this block right here, on the far right in the middle. Okay, I cannot place an 8 in the middle column because I already have an 8 down here. I cannot place an 8 in the top row of that block of 3 because I have an 8 right here. I cannot place an 8 in the middle row because of this 8 right here. So that gives me only one option to place an 8 in this group, and that would be right here. So I have 8 of my 8s so far. So I only have 1 8 left to go on this board. So I'm going to pause the video shortly, or very quickly, and clean up the board again, and then I'll show you how to find that last 8. Okay, so I've cleared the board of all but my 8s now, in terms of the markings. So I'm going to circle all the 8s on the board, find them all. So there's 1 here, 1 here, 1 here. I've got 1 here, 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 and here. So remember, the way this works is that every row, every column, and every block of 9, 3 by 3 block of 9, is going to contain all 8 or all 9 different digits. I have 8 8s already on the board, which means I only have 1 place left to go to place an 8. So the only block of 9 that doesn't contain it is the top right, which is this block right here. So I need to find out, do I place it in the top row, in the middle row, or in the bottom row? Do I place it in the left column, the middle column, or the right column? So I'm going to eliminate rows and columns as I can find them. So in the very top row, I have an 8 in the second group, so that can go. In the third row from the top, I also have an 8 already, so that row is no good to me. In the second column from the right, I have an 8, so that column is no good. And in the third column from the right, I also have an 8, so that column is no good to me. So I've eliminated all of these spots right here. The 8 can go in none of those spots. So the only place I can place an 8 is in this block right here. So I have an 8, and that gives me the 9 that I need. Okay, so I'll pause the video very quickly, and I'll clean up the board again. Okay, so I've cleared the board. I'm going to do one more number with you to make sure that you're able to follow along and determine what we're doing here. So I also noticed at the very beginning that I had a lot of 6s to start. So I'm going to circle all my 6s that are currently on the board right now. I have a 6 here, down here, in the middle, in the top right, and in the middle right. So I also have 5 6s to start. Again, having 5 of a digit already means there's only 4 more to put out there. It means there's not many different places it can go. So often the numbers that are most frequent are the ones that you should consider finding others for. So once again, if I look at the far left column, this whole column is no good to me because I have a 6 in it already. The next column over, I also have a 6 in the column already. So it's no good to me. Also, the 6s are in the top left and in the bottom left. So in the top left and bottom left, I already have a 6. I cannot put another 6. There isn't a 6 in the middle left block of 9, which is this block right here. So I can put a 6 in one of the 3 available slots. But I also have to look and find where else 6s might possibly be. And in the 4th row from the top, there's already a 6. So I can eliminate that row. And in the 4th row from the bottom, I find a 6. So I can eliminate that one. So once again, I've been able to eliminate all my possibilities down to one empty square in which I can place a 6. And that would be right here. So I can place a 6. That means I now have 6 6s. And you can continue doing this. You can try this over and over again. Make sure that you count each 3 by 3 block to make sure that you have all the different digits from 1 to 9, as well as having all the different rows and all the different columns. And eventually you'll be able to find the answer to this. So to summarize this section, there are lots of different strategies you can use when you're looking to solve puzzles or win at games. And there are lots of other examples you can find in your textbook that you can try for this. Or any type of, a lot of board games you can use many different strategies as well. So the strategies you can use, we can do a guess and check. We can look for patterns. We can make a systematic list. We can draw our model. We can eliminate possibilities, simplify the original problem, work backward, or develop alternative approaches. And we looked at a lot of these different types of examples in just a few examples that we went through in this particular section. So again, it's a good idea to try to solve any of these. And after this summary page, I'm going to have the Sudoku puzzle's answer. So if you want to wait a few seconds, that'll appear on the screen. So here's the Sudoku puzzle completed. The black numbers are the numbers that we were given initially, and all the red ones were the numbers that were filled in. And you'll notice that every single column and every single row and every block of 3 by 3 contains every digit from 1 to 9 and only contains one of each digit. So that block there contains it. We can see that this column right here contains all the digits from 1 to 9. And we can see that, for instance, this row right here contains all the digits from 1 to 9. So good luck with your gaming.